Now we're ready to take a look at some changes that matter can go through, and there's two types of changes. The first one is physical change, and a physical change basically means that you still have the same substance before and after, so it retains its chemical identity. That means that it, on the molecular level, will still look the same. So the way the atoms are attached or not attached will still be the same when you have a physical change. If it's still the same substance before and after, then we will notice that it also still has the same chemical properties. In some cases, you might see the physical properties change, though. Now, what we're talking about here is if I have a change in state of matter, such as water, liquid water changing to a gas, I know that steam does not look the same as water, so it doesn't have the same density, it doesn't have the same specific heat. Those are all examples of properties that we've already talked about, but it will be the same molecular makeup and will still have the same chemical properties. So again, there will be some defining characteristics that are still the same, but there may be some slight change in physical properties if we're talking about changes in state of matter. Arrangement, location, or speed of particles may change. So again, we talked about the differences between the states of matter, solid and liquid and gas, and how their particle arrangements vary. So when we're talking about physical changes, again, another very common example of physical change is the changes of state. So I know that going from a solid to a liquid, the particles have more energy, and therefore they are able to move past each other more easily. But they're still the same particles, and they still have the same makeup. So that's what I mean by arrangement, location, and speed of particles changing. Some physical changes can be undone. Again, we've all seen changes in state happening reversibly. So we've seen ice melt, we've seen that water refreeze, we've seen water boil and change to a gas, steam, and then that steam condense and turn back into liquid water. So those are the types of physical changes that can be undone. There are some physical changes that cannot be undone. For example, if I rip a piece of paper or break something in half, those are physical changes. We're not changing the chemical structure, but they obviously can't be undone, at least not completely and reversibly. So if we take a look at on the molecular level or on the atomic level, when we describe physical changes, we're talking about this basic unit. So we'll pretend these are atoms. This is a circle attached to a square. This is our little molecule. In a physical change, let's say I have a couple of these and they happen to be arranged where it's a circle and square on top of a circle and square. The arrow indicates a change is happening, and so that's going to be a common notation in here. And what we find on the right-hand side of the equation here is that the circle and the square are both still intact and touching each other, but the pairs or the molecules of circle and squares, those have been separated. So their orientation, their arrangement in relation to each other has been changed. So again, that's what's happening on the atomic level, molecular level, in terms of physical changes. When we look at our other type of change, that's a chemical change. This is where we've got a new substance being formed, and so this is obviously a big part of chemistry that we're going to be studying. This is also what we're going to refer to as a chemical reaction. And in a chemical change, you have taken one thing or a couple of things and made something completely new. And the new substance or new substances will have different properties than the original substance. So those characteristic properties that we talked about, density, color, odor, those are all things that will be different with the new substance. So if we're observing new characteristics, that must be an indication of a chemical change. What's happening with a chemical change is that atoms have been rearranged. So bonds might be formed, bonds might be broken, and we no longer have the same molecular or molecular makeup that we did originally. So if there were single atoms before, maybe now they've combined, or if there were molecules with atoms joined together, maybe now they've broken apart and reformed or reattached to new atoms. Energy is produced or absorbed. So in order to form bonds and break bonds, there's going to be a change in energy. If you take a more advanced chemistry course, you will learn more about those energy changes, but we will probably be able to detect in a lot of cases energy being absorbed or produced by changes in temperature, seeing light or heat being released. In chemical change and chemical reactions, we're going to call the original substance the reactant, so that's the thing that reacts. We will call the new substance that's formed a product because that is the thing that's produced. And so again, looking at this one molecule depiction, If I have a chemical change, what's happening on the atomic level or molecular level is, so notice we've got the same thing we started with on the left-hand side, on the reactant side, in the physical change example. The difference then is that instead of on the right-hand side being left with our same original molecule circle attached to the square, we've now got two circles attached and two squares attached. So that means that the makeup of this substance is different on that molecular level, and we should then also detect a difference in properties, so a different appearance, a different odor, a different density, a different, you name it, it's different properties because it's not the same thing anymore. Notice that in either of these examples, physical or chemical change, mass is never created nor destroyed. So you notice in my depictions, if I had two circles on the left and two squares on the left, I have two circles on the right and two squares on the right. And that's something that we'll talk about in the next unit. But that's what we're depicting with these chemical equations that we'll eventually get into writing in symbols for. All right, so how do I tell that I've got a chemical change versus just a physical change? Well, there are some things we can look for, and we're looking for signs that there's a new substance there. The evolution of a gas. So I know when I put water on a hot plate, eventually bubbles form because I've seen water boil, and we just said that boiling water is a physical change. So when we're talking about evolution of gas, we're talking about adding two substances together, not adding any heat necessarily, but we see on contact those two substances now producing a gas. Another example is formation of a precipitate, so a solid being formed when two solutions are mixed. I'll show you an example of that. And these are, if we're talking about two clear liquids, now all of a sudden forming this cloudy precipitate, a solid, then that is a sign of chemical change. Release or absorption of energy, so I already mentioned this, but if it feels hotter or colder, the vessel that the reaction is taking place in, if you see light being released, you see flames, sparks, whatever, that's a good sign of chemical change. And lastly, a color change or other change in physical properties. So now I'm observing that the same color is not there before and after. That would be a sign that something new must have formed. First, we're starting here with some evidence of chemical change, and this is evolution of a gas. So notice that we started with a solid powder and added this clear liquid, and bubbles were formed. So clearly it wasn't just a phase change where water was being heated and it was boiling, changing phase. It was a solid and a liquid that caused the bubbles to be formed. So the gas must be a new substance. Next example that we have is formation of a precipitate. So notice this is a clear colorless liquid. There's going to be another clear colorless liquid added to this solution, and we will notice the precipitate forming. So there it is. It happens to be a yellow precipitate. Not all precipitates happen to be yellow. They can be different colors, but again, notice that it looks very cloudy. If this settles out, then you'll recognize it as a solid at the bottom. And again, we started out with two clear solutions, so that is a sign of chemical change. Next, we've got the evolution of heat or light, and so this is potassium permanganate on the plate here. They're going to add some sulfuric acid, and we'll just time lapse a little bit here to there, and they add another liquid in, and notice again there was not any match used to light that. This is surely a chemical reaction that started by that liquid being added to the solid on the plate there. And again, the evolution of energy, as in this case flame, that indicates a sign of chemical change. Lastly, we've got the rusting of this iron nail file, and this is time-lapsed, but you can see that the liquid that it's in is starting to turn this orangish color. And so there's a sign of chemical change, is that when the rust forms, a change in color. There's a change in properties. We know the surface is not going to be as smooth, as shiny. It's going to have that red, crusty rust on it, indicating a chemical change.